Okay, everyone, we are continuing with learning about logarithms. Today we're going to start solving logarithmic equations. We already learned that you can use a logarithm to solve exponential equations. But now we're starting where equations already have logarithms in them. Today is going to be the somewhat easier day. It might get a little more complicated after this. But just like with exponential equations, there is what we call a one-to-one property here. And basically, if you have the same logarithm on both sides of the equal sign, you're allowed to just cross them out. And then what you have left over is an equation that you solve using skills that you've already learned. So number 2, these are both common logarithms. Just to review, if there's no base, they are automatically base 10. So they match, so they cross out. What we have here, we can now maybe get the like terms together by adding 5x to both sides. 4 plus x equals negative 7. Subtract 4, x equals negative 11. And so that hopefully seems fairly simple. Let me scroll down. I want to try and get in the habit of checking my work as I go. Of course, you might be getting dizzy. Yep, there it is. So yeah, if I start moving the screen all over, it might not be the best thing for you to see. Number 14. Again, when the logs are the same on both sides, they cross out. Negative v equals 6. Isolate v by dividing by negative 1, and you get v equals negative 6. And it's done. That's all there is to it. Let me go down and check number 4. There it is. So, how can these be made more difficult? Well, we're about to get there. Number 6. So this logarithm cancels out with that logarithm. We get 30 plus 3m equals m squared minus 4m. What we have now is an equation with a squared term in it. That means it's called a quadratic. To solve quadratic equations, there's a few things. You need one side to equal 0. So we've covered this over and over and over now. Feels like it's just crazy. So we get m squared minus 7m. Now I can subtract 30 on both sides. And I get 0 equals m squared minus 7m minus 30. To solve a quadratic like this, you have a couple options. You can either factor or you can use the quadratic formula. And most of the time, factoring is preferable. So we need the two numbers that multiply to negative 30 and add up to 7. Well, let's see, 5 times 6, no, but 10 times 3. A negative 10 and a positive 3. They multiply to negative 30, they add up to negative 7. Now if I set each one of these equal to 0 and solve them, m equals 10 and m equals negative 3. So I have these two answers. Okay, a little bit more work. It starts out easy. Cross out the logarithms. From that point on, it's not that it's difficult because we've learned this and we've done it over and over, but it is tedious. There's steps that you have to do. Let me go down and check number 6. And yeah, 10 and negative 3 are the solutions. All right, let's look at number 8. These cross out. R squared plus 31 equals negative 12r minus 1. Again, it's a quadratic. We need one side to equal 0. Since the r squared is already on the left, hold on, I gotta make that r look more like an r. Okay, I don't know, that's pretty ugly too. All right, we need one side to equal 0. Since the r squared is already on the left, I'm gonna move the other two terms over. So I'm gonna add 12r, add 1, add 12r, add 1. So I'm kind of combining steps here. I've done it in class like this a few times. Hopefully that's not too confusing for you. So I have r squared plus 12r. Those are not like terms, so you can't combine them. You just rewrite them. Plus 31 plus 1, that's plus 32. Those are like terms. That's fine. Since everything cancels here, we get 0. Now we need to factor this by thinking of two numbers that multiply to 32 and add up to 12. Well, if you know your times tables, that's 8 and 4. 8 times 4 is 32. Of course, 8 plus 4 is 12. And they're both positive. Set them both equal to 0. And then when you solve them, see, you subtract 8, you're going to get negative 8. And when you subtract 4, you're going to get negative 4. And these are my answers. Let me scroll down to number 8 and check and see if those are right. Yep, right there. -8 and -4. Now, let's look at number 10. The logarithms cancel out. That's what we call the one-to-one property. They match up, they cancel out. So we get -36 plus 3x equals x squared minus 10x. One side has to be 0. Since the x squared is already on the right, I'm going to keep it there. I'll subtract 3x, and I'll go ahead and add 36. Everything on the left completely cancels out. I get 0. Over here is x squared minus 13x plus 36. I'll factor this. What numbers multiply to 36 and add up to 13? 6 times 6, but 6 plus 6 is 12, not 13. 9 times 4. 9, yeah, there we go. 9 and 4. To add up to -13, they have to both be negative. So they multiply to positive 36, they add up to -13. Set each one equal to 0. Add 9 over to here, you get x equals 9. Add 4 over to here, you get x equals 4. Now I'm going to go down and check these. Notice I haven't circled them yet because I just know what's going to happen here. Number 10, it says no solution. So what's up with that? So here's the deal. When you solve an exponential equation, and the same thing applies to every problem I've done so far, it just hasn't happened. But here's the deal. It's possible for you to do all the work right, and then those answers are technically wrong. Remember, with any equation, you can plug your answer back into the problem and check and see if it's right. So let's plug in a 9. Log base 6 of -36 plus 3 times 9. Does that equal log base 6 of 9 squared minus 10 times 9? Well, we're going to be doing logarithms here, so a calculator would help. I should have had this pulled up already. Sorry about that. So let me do this in a calculator. So function, miscellaneous, log a. The base is 6, and I want to do -36 plus 3 times 9. And that says undefined. As it turns out, if you weren't using a calculator, you have -36 plus 27, log base 6 of -9. You cannot take a log of a negative number. Log of any negative number is undefined. It just can't be done. If you think about it, it makes sense. How many 6's can you multiply together to get -9 for an answer? That's how logarithms work. That's the question we're answering. Well, you can multiply a fraction of 6's together to get a 9. That's possible. But you can't multiply positive numbers together and get a negative answer. That's not possible. It just can't happen. So 9, it turns out, right here, is what we call an extraneous solution. And then let's look at the second solution, 4. It's going to be basically the same way. Log base 6 of -36 plus 3 times 4. Does that equal log base 6 of 4 squared minus 10 times 4? And notice I didn't even work out the right-hand side here on the calculator. If I did, that would also say undefined, but you get undefined once, you're done. You can just say, oh, that's extraneous. So here, let me type this in. Function log a base 6 and then -36 plus 3 times 4. There you see it again. This is didn't mean to do that. This is undefined, just like that was undefined, which means this answer is also extraneous. Well, if both answers are extraneous, that means this problem has no solution. So the rule is you're always supposed to check your work by plugging a number back into logarithm problems to see if you get an extraneous solution. On these first couple, it's just not going to happen. They're very basic. But when you get to having squares in there or higher powers, that's when you have to really start worrying about it. So I'm going to do number 12. I'm not going to look down at the answer key. I'm going to check the answer on my calculator and see if it's extraneous or not. So we start by canceling those out. 2x squared plus 15x equals negative 50 plus x squared. I'm going to go ahead and subtract x squared to bring it to that side, and I'll go ahead and add 50. That cancels everything out here and gives me that 0. On this side, 2x squared minus x squared is x squared, plus 15x and then plus 50. Those are not like terms, so I can just bring them down. So when you solve a quadratic, one side has to be 0. That's what we've got. Now we're going to try to factor this. What are two numbers that multiply to 50 and add up to 15? Well, that's pretty straightforward, I think. 10 and 5, right? 10 times 5 is 50. 10 plus 5 is 15. Set these both equal to 0. You get x equals negative 5. X equals negative 10. If you bring this over, it becomes negative. If you bring that over, it becomes negative. So let's see. Are these extraneous solutions? Let's check the answer. I'm going to plug in the negative 5. And does that equal that? So I just copied this down, but I plugged negative 5 in for the x's. Let me see what happens here. So now this is a common log, so I'm going to use that log button. 2 parenthesis negative 5 outside parenthesis square plus 15 times negative 5, and that says undefined. The fact that that's undefined tells me that this is an extraneous solution. No good. Does that mean negative 10 is also going to be an extraneous solution? Not necessarily. So now I need to do log 2 times negative 10 squared plus 15 times negative 10 equals log negative 50 plus negative 10 squared. Wow, just barely squeeze that in. So function log 2 parenthesis negative 10 parenthesis squared plus 15 parenthesis negative 10 parenthesis. Okay, so that's approximately 1.69. We'll call it 1.7 for now. I know I said 4 decimal places, but let's just, I'll tell you what, I'll leave it on the screen there so we can compare. Now we got to do the other side of the equal sign. Log negative 50 plus parenthesis negative 10 parenthesis squared, and that's also the same 1.7. So that really does work. That means negative 10 is a true solution to this equation. So we got 2 solutions. It turns out one of them was extraneous. Let me check the answer key, and there it is. So, okay, what do we have here? It starts out pretty simple, pretty basic. You cross out the logarithms, solve the equation that's left, and you get a couple problems like that. Then you get into some quadratics, so you have to remember how to solve quadratics by doing the factoring and deal with that. And a couple of them are going to work out fairly smoothly, shouldn't be too big of a problem. Then you're going to get to some where you start having solutions that don't work. Now you're going to scroll down and look at the answers and see that, but what I'm asking you to do is to go back and see how you would prove that to yourself on the calculator. So I'm going to be trusting you on these problems that after you've done the work, you're actually typing the problems into the calculator to see what it truly means to get extraneous solutions. As always, show your work. There is no way that a human being can look at these problems and just say, oh, the answer is 2. It's going to take steps, and I want to see the work steps. You don't have to do every single step the way I do. If you do some of the work in your head, I understand. I show every step as the teacher. You're going to skip some of it, but I cannot just look at a list of answers and give you credit for that. Okay? As always, if you have questions, email me or drop some questions in the comments section on Google Classroom. Good luck, and we'll